Hey everyone, welcome back. Exciting times today. We are going to learn about a new type of reaction. If you remember back, we've already talked about synthesis, decomposition, and combustion. Today, we're only going to focus on one more. So we're adding a fourth to our list. We're going to talk about single replacement. That's right. So single replacement reactions. Good stuff. One element replaces another. Seems kind of simple. Reactants must be an element and a compound. So we have one reactant is an element all by itself. The other thing is a compound, meaning two or more elements. The products will be a different element, so a different thing that's by itself, and a different compound, because one of the elements is going to switch places with another. Either the metal or the cation or the non-metal anion will trade places. Okay? For example, if I have this general formula right here, we have A plus BC. So A right here represents an element. BC right here represents a compound. Yep. And then we have a new compound over here. A is now compounded with C. And we have B all by itself as an element. So right here, when B was in a compound, now B is all by itself. So lonely. A real example, we have silver nitrate. So we have a compound, and we have sodium all there, right there by itself. And on the product side, now we have silver all by itself, and sodium is in a compound with nitrate. So one thing just switches places. The element that's by itself now joins the compound, and the cation in this case is all by itself as an element. Okay. Another example right here, we have potassium bromide plus chlorine. Chlorine is all by itself. Chlorine wants to be in a compound. So what it's going to do, it's going to kick bromine out. So now bromine on the product side is by itself as an element, and we have potassium chloride as our compound. That seems pretty simple. All right. One thing about this, they don't always happen. So we're going to have to look at this chart right here to figure out when a single replacement reaction will happen and when it won't. So some of our metals are more active than others. It's true. A more active metal replaces a less active metal. So all these things up here at the top, lithium is our most active metal. Gold is our least active metal. Okay. More active means it replaces. If it's higher on this list, if it's higher up, like lithium, it's the highest up, it will replace any of these things that it's lower than. If the element by itself is higher, the reaction happens. If the element by itself is lower, it does not happen. Okay? All right. Metals will replace metals. Hydrogen, in this case, since you know where hydrogen is on that far left side of the periodic table, because it's way over there on the left side, it's going to act like a metal in these situations. So metals will replace other metals, and they will replace hydrogen. For example, I have K plus AlN. K is potassium, Al is aluminum, N is nitrogen. So potassium and aluminum, those are our two metals. So I'm going to have to look over here on my list. I'm going to have to decide the thing that's by itself right here. Potassium is by itself. Is it higher on the list? Let's see. Oh, there's potassium right there, the second one. Now, let's make sure aluminum is lower on the list. There it is, way down there. So, in this case, potassium, because it's by itself and it's higher on the list, this reaction happens. Another example, zinc and hydrogen and chlorine. Hydrogen and chlorine are in the compound, so zinc is by itself. I have to make sure zinc is higher than hydrogen on the list. So right here, zinc is right here in the middle, but hydrogen's way down here. So because zinc is higher on the list, this happens. Okay? Sometimes you see water as H2O. Sometimes you see water as HOH. This way, we can keep that hydrogen in front. It'll help us when we're deciding if we're going to have a reaction or not. So a metal will replace the H. All right. Sodium is a metal, and it's going to mix with water, HOH. So sodium is only going to replace this H that's in front. If it happens, we have to check our list. So we're looking. Look at that right there. There's sodium. So since we have sodium way up here, H is way down here, this reaction happens. All right. So some more examples. Fe. Oh man. What is Fe? What is Fe? Oh yes, it's iron. Cu. Cu. Copper. So iron and copper. I have to look up where iron is. I have to look up where copper is. Is iron higher on this list? Iron's way up here. Copper's way down here. So this is going to happen. What do I have to do? Let's go back here. What we're going to do next, we are going to finish up this equation. Since these things switch out, we're going to have copper by itself now. Plus iron sulfate. And then we're also going to have to make sure they're balanced. But we already know how to do that. We've been practicing balancing for days. All right, try another one. PB. What is PB? PB is, man, I don't see anything up here that looks like PB. What could it be? What could it be? PB is, it's lead. That's right. PB is lead. And it's mixing with KCl. So K, that's potassium. Is lead higher than potassium on the list? Is lead higher than potassium? No, lead is lower. So this is no reaction. Look at that. That's some serious drawing with a mouse skills. All right. So questions about that? That seems pretty simple, right? Okay. Aluminum plus HCl. So the Al and the H, they're the ones we're dealing with. I have to find aluminum on this list. Aluminum. There we go. Aluminum's right here. It's kind of in the middle. And it's definitely higher than hydrogen on our list. So this is going to happen. And this right here, we're going to have Al with chlorine now. Plus H is going to be by itself. We're going to have to remember something. H, hydrogen, it's a diatomic element. It always has H2. So when it's by itself as an element, it has that little bitty 2 right there. And Al, when I look at the periodic table, aluminum, oh my goodness gracious, there it is. It has a +3 charge because of what column it's in. Chlorine has a -1, so I'm going to have to take this +3 over here from aluminum, move it down there. So it's going to actually be AlCl3 is the formula for aluminum chloride. Now I'm going to have to go back to the drawing board, and I'm going to have to figure out how to balance this equation. For one thing, we're going to have to put a 6 right here. So now I have 6 hydrogens, 6 chlorines. I'm going to put a 2 right there. Now I have 2 aluminums 2 times 3 is 6 chlorines. I have to put a 2 right here for 2 aluminums. And we have 6 hydrogens on this side. We're going to have to put a 3 right there. So that's a harder one to balance, but definitely doable. So 2, 6, 2, 3. And there is my balanced equation. Just an example of how we're going to do this. So yes, we're going to have to be able to look at the activity series to decide if things are going to be replaced or not. We're going to have to predict products. That's what this is called. When I wrote out what these products are going to be, we're going to have to be able to predict them by using the activity series. Then we have to write the correct formulas. And then we're also going to get to balance it. Hey, we already know how to balance. Y'all are good at that now. You can look at this chart. If the thing that's by itself is higher up in the chart, it'll happen. Okay, so y'all can do that. Then it's just writing the chemical formulas. Y'all have been writing chemical formulas for a long time now. Any questions about this? Excellent. We will have some practice. And the practice is going to look, it's going to be pretty cool. So we have practice right here. And let's go for this pretty pink color. All right. So for this activity series practice, for each of the following elements, underline the one that could replace the other. And we know from what we've already learned, whatever's higher up can replace. So in this case, we have calcium and tin. We have to find those two things on our list. So calcium, that's Ca. There's Ca right there. We have calcium. And tin, that's Sn. Tin is Sn. We have that right there. So we have calcium, we have tin. Calcium is higher up on the list. When it's higher up on the list, that means it could replace the other. So we're just going to underline calcium. So that's all you're doing on this first part. Y'all can handle that. For the second part, it says, if it will happen, write yes in the blank. Okay? If it will happen, write yes. So we're going to have to look at our thing that's by itself. Lithium right there. Is lithium higher up on our list? So we're going to have to go back to our list. Is lithium? Oh, it's the highest one up there. So this will happen. So we write yeah. So you can do that for these. You're doing the same thing right here. But the other thing I want you to do, you know what these blanks in front are going to do for us? I want you to balance. So D, E, and F, we are also going to balance them. Y'all can handle that. Down here is just more practice predicting the products. So you are going to predict the products. If you find one that does not happen because of the activity series, you write no reaction. Otherwise, predict the products, write them out there, and balance the equations. Balancing the equations is a very important part. All right. Sounds good. Thank you for your attention.